The last type of word problem we're going to look at in section 7.7 is the work problem, where in this section, a work problem is when two or more people or machines are working together to complete a single task. So, for example, let's say I can design a website and it takes 7 days, whereas my buddy Marty can design, apparently that's not how you spell design, can design the same website in 4 days, because he's like a computer science major, man. How long will it take to design the website if we work together? So one thing I know for sure here is my answer should make sense when I'm done. If I can do it in 7 days and Marty can do it by himself in 4 days, then working together, we should be able to get it done in less than 4 days. So let's see how we're going to do this. Now, the idea is we're going to break this up into pieces. So the first thing that we want to take a look at here is our units of time. We're talking about days here, days of work. So if I want to talk about how many days it's going to take us both to complete this, then what I want to first do is find out exactly how much work each one of us can do in a single day. So if I can do the whole site in 7 days, then I can do 1/7 of the site in a single day. Likewise, if Marty takes 4 days for the whole site, then he can complete 1/4 of the site in a single day. Now, the reason that that's important for us to do is because if I know how much I can do in 1 day, and I know how much Marty can do in 1 day, then if I just add those two together, I know how much we can both do in a single day. So, let's see. I would have something like 1/7 plus 1/4. And how much, so this is me in 1 day, Marty in 1 day, and what that's going to total is 1 over some unknown amount. This is how much, how much we both do in 1 day. And if I can find out how much we can both do in 1 day, then X is how long it takes both of us to complete the job. So let's go through some guidelines here before we do this problem. Guidelines for solving work problems. Number 1, determine the time for each individual or machine to complete the single job. Well, we did that. That was 1/7 for me. Oh, sorry. Me, 7 days. Marty, 4 days. So it says here, determine the time for each individual or machine to complete the single job. We have that there. If one of those times is unknown, declare it as a variable. Well, we actually know both of those times, so I don't need to declare it as a variable. And then it says, do the same for all people and machines working together. What does that mean? Well, time for me and Marty. That I don't know. That's going to be my variable. So I declare X the time required for both of us to finish the job, complete the website. Okay, so in our next step, determine what fraction of the job each person machine can complete in a single unit of time, and do the same for everyone working together. Well, let's see. If my unit of time here is, as we said before, days, and we actually already did this above, I can do 1/7 of the job in one day. Marty can do 1/4 of the job in one day. And if it takes X days for both of us to do the job, then both of us working together is 1/X of the job in one day. So then we create the equation. 1/7 plus 1/4 is equal to 1/X. And we solve. So in order to solve this is a rational equation. The LCD here is going to be 28x. So we'll take this equation. We'll duplicate it. Scooch this up just a little bit for some extra room. We'll multiply through by the LCD. 28x over 1 will distribute to all terms in the equation. And we'll get 28x over 1 times 1/7 plus 28x over 1 times 1/4 is equal to 28x over 1 times 1/x. Doing some quick cancellation here, we'll be left with, let's see, 7 goes into 28 4 times, 4 goes into 28 7 times, and here the x's will cancel, and we're left with 4x plus 7x is equal to 28, or 11x equals 28. So if we divide both sides by 11 here, we get 28 over 11. And if we get out a calculator and we determine exactly how much that is, 28 divided by 11 should be more than 2, but less than 3, about 2.5 approximately. 2.5 days. So, in our last guideline, we'll answer the question in a sentence. Working together. Marty and I can design the website in about 2.5 days. So that's the idea. We're going to take a look at a couple more examples here using the exact same guidelines. So let's go through it. Example number 5, Logan can tile the bathroom in 4 hours. His partner Lance can do the job in 6 hours. How long will it take Logan and Lance to tile the bathroom working together? Well, let's see here. In guideline number 1, Logan can do the job in 4 hours. Lance can do the job in 6 hours. And together, well, that's what we're actually being asked, right? So that's going to be X hours. So we're working in hours here. Those are our units of time. So in step 2 here, we'll turn all of that into 1 unit. Logan can do 1/4 of the job in 1 hour. Lance can do 1/6 of the job in 1 hour. Together, they can do 1/x of the job in 1 hour. So step number 3, we'll set up our equation. Whatever Logan can do in an hour plus whatever Lance can do in an hour totals or is equal to whatever they can both do in a single hour. And so here we have an LCD of 12x. So let's get started on solving this. For step number 4, we'll multiply through by the LCD. And 12 divided by 4 is going to give us 3 with an x. 12 divided by 6 is going to give us a 2 with an x. And 12x divided by x is just going to be equal to 12. So 5x is equal to 12. So x is equal to 12/5, which is 2.4 hours. Or if you want to get very technical, about 2 hours, 24 minutes. So for part 5, working together, Logan and Lance can tile the bathroom in 2.4 hours. The end. So those are pretty straightforward until we get to example number 6 here, where there's a little bit of variation. Let's see. An empty tank has 2 inlet pipes. So let's see. Here's our empty tank. Let's duplicate that. Come on, duplicate. No. Just move it. Yeah, there we go. And we have pump number 1 and pump number 2, and they're both dumping chemicals into our tank. And it says the first pump can fill the tank in 30 minutes. So for our first guideline, pump 1 can do the job in 30 minutes. Pump 2, it actually doesn't give us any information about. So pump number 2, X minutes. But it does say that working together, both pumps can do the job in 20 minutes. How long will it take the second pump to fill the tank by itself? All right, well, in 1 minute, pump number 1 can do 1/30th of the job. Pump number 2, well, I don't know how long it takes pump number 2, so this will be 1/x. And together, if it takes them both 20 minutes, they'll do 1/20th of the tank. So in number 3, however much pump 1 can do in 1 minute, plus whatever pump 2 can do in 1 minute, is equal to whatever they can do together. And it's very similar to the previous example. It just happens that our variable is in a different location. So for 4 here, we'll multiply through by the LCD. Let's see. Apparently 60x. As we distribute, 60x over 30 is going to give us 2x. 60x over x is going to give us positive 60, and that's going to be equal to 60x divided by 20, which is 3x. Solving for x, we're going to subtract 2x from both sides, and it looks like x is going to be equal to 60, and so pump 2 takes 60 minutes to fill the tank alone. And that was step 5, answering the question in the form of a sentence. And that's working together.